The ocean looks familiar, right up until it doesn't. A shimmer of sunlight, a lacework of waves, the last easy breath of blue. Then the light thins. Colors drain away in a quiet surrender. Reds vanish first, swallowed by water. What remains is a colder palette and a question. Why does life start to look unreal down here? At the surface, animals are built for a world of air and light. Shapes are streamlined, patterns are bright, signals are visible. But as we descend, the rules rewrite themselves. Pressure begins its slow squeeze. Sound carries farther than sight. Food arrives like a rumor. And evolution, patient, unsentimental, starts spending its budget differently. Eyes grow larger, then sometimes disappear. Bodies soften because bone is heavy and sinking is costly. Mouths widen because a meal might come once a week or once a month. The deeper we go, the less animal seems like a single idea. Down here, survival favors whatever works, even if it looks impossible. This is not a story about monsters. It's a story about physics, about energy, about what happens when life is forced to make a living where almost nothing should. We're going down, past the last place a human body can endure, past the last green hint of day. And with every meter, the ocean grows quieter and stranger. At around 200 meters, daylight becomes a memory. This is the twilight zone, the mesopelagic, a world of dim blue, like the last minutes before night. Here, vision still matters, but it's a different kind of vision. Not for color, for contrast. Predators look upward, searching for silhouettes. Prey look downward, searching for the faintest movement. Everyone is hunting, everyone is hiding, so bodies change. Some animals turn transparent, not invisible, just harder to outline. A moving gap in the water. Others turn mirror silver, reflecting the faint light so they blend with it. A living disguise. And then there's the strangest trick of all, counterillumination. Some fish and squid produce light on their bellies, not to be seen, but to erase their own shadows. A soft, measured glow that matches the brightness above. It's camouflage made from fire. But if light is so scarce, why waste energy making it? Because in the deep, light is no longer just illumination. It's language. It's bait. It's a weapon. Bioluminescence isn't one invention. It's many, evolved again and again. Different chemicals, different organs, different purposes. A million separate solutions to the same problem. How do you survive in the dark when everyone else is adapting to the same darkness? We're still not deep enough to see the full answer. Below us is the bathypelagic, the true midnight. And down there, light doesn't come from the sun. It comes from living things. 1,000 meters down, night becomes permanent. The temperature drops. The pressure climbs, crushing, relentless. Every square centimeter is squeezed by a weight you can't imagine. And yet life persists. Here, the ocean looks less like a place and more like a condition. Cold, dark, compressed. So why do animals look more alien? Because the deep sea punishes wasted energy, and it rewards extremes. Food is scarce, falling from above as marine snow. Flakes of dead plankton, fecal pellets, tiny fragments of bodies. It drifts like ash. In this world, a small advantage is everything. Some animals grow enormous mouths and expandable stomachs. Not because they're greedy, because you can't afford to refuse a meal. Anything you catch might be the only thing you see for days. Teeth become needles and traps, angled inward. A prey item that slips once might never be replaced. Bodies become loose and flexible, built to handle pressure by not resisting it. In the deep, being rigid can be a weakness. Eyes can become huge, tuned to the faintest glimmer, or they can shrink to nothing, because sight is useless when there is no light to see. Then the lights appear. A dot, a pulse, a slow, deliberate blink. Some creatures flash to confuse. Some glow to signal a mate. Some mimic the lights of others, luring prey toward death. The deep sea is filled with messages, but most of them are lies. And as we descend further, another force takes over. Not just darkness, but distance. Down here, finding anything, food, a partner, even a threat, can take a lifetime. So evolution makes the unthinkable sensible. Meet the anglerfish, an icon of the deep. Not because it's evil, because it's honest about the math. In the darkness, hunting is expensive. Chasing burns energy you may never replace. So the anglerfish waits. A living lure dangles from its head, tipped with light. Not a lantern for seeing, a trap for being seen. Prey approaches the glow like a moth to a candle. And then the mouth opens wider than seems possible. But the anglerfish's strangest story isn't the lure. It's reproduction. In some deep-sea species, males are tiny compared to females. Because in a vast black ocean, finding a mate is harder than finding food. So when a male finally finds a female, he bites and never lets go. Over time, their tissues fuse. His circulatory system connects to hers. He becomes, in effect, a permanent source of sperm, a biological solution to loneliness. It sounds grotesque in human terms, but in the deep, it's efficiency, a guarantee against never meeting again. And the deeper we go, the more we see this logic. Life not as beauty, but as strategy. Gigantism appears in some groups. Jelly-like bodies swelling large, drifting slow, conserving energy. In other places, animals shrink because small requires less food. Some creatures become living nets. Some become living blades. Every alien feature is a receipt, proof of what it costs to exist here. But there's another reason deep-sea life feels so unfamiliar. It's not just adapting to darkness and hunger. It's adapting to a world that can change in an instant. When a carcass falls from above, a whale dies near the surface, and for a time, the ocean barely notices. Then the body sinks, down through the twilight, through midnight, through the pressure and cold, until it meets the seafloor like a slow catastrophe. A whale fall is a sudden continent of food, an ecosystem delivered in silence. First come the scavengers, sharks, hagfish, crustaceans, stripping flesh in a frenzy that can last months. Then the opportunists move in, feeding on what remains. Worms, snails, strange soft-bodied drifters, life assembling around death. And finally, something even more alien begins. Bacteria break down the bones and release chemicals, including sulfides, fuel for chemosynthetic microbes. Life powered not by sunlight, but by chemistry. An entire community living off a reaction. This is the deep sea's other sun. Not a star, but a molecule. The farther down you go, the more the ocean resembles another planet. Not because it's imaginary, because it runs on different energy. At hydrothermal vents, superheated water pours from the Earth's crust. Minerals precipitate like smoke. And around these vents, animals thrive in dense clusters, fed by symbiotic bacteria that turn chemical energy into food. Giant tube worms without mouths, clams and mussels hosting microbes, crabs walking through warm currents in freezing darkness. It's not magic, it's metabolism, and it suggests something unsettling. If life can flourish without sunlight here, where else could it flourish? Below us is the Hadal zone, ocean trenches, the deepest places on Earth. And there, the alien feeling reaches its peak. The trench is not just deep, It's extreme in a way that warps the imagination. At 11,000 meters, in places like the Mariana Trench, the pressure is crushing, over 1,000 times atmospheric pressure. A human body would not survive it. A metal hull can fail under it. And still animals live, not in abundance, but in persistence. Small amphipods, delicate sea cucumbers, snailfish drifting like pale ghosts. Their bodies are built from compromises. Proteins adapted to function under pressure. Membranes tuned to stay flexible. Chemistry adjusted to keep life from seizing up. In the deepest dark, there is no reef, no forest, no horizon. Just sediment, slow currents, and the occasional fall of food from above. So why do deep-sea animals look more alien the farther down you go? Because the deeper you descend, the more Earth becomes unfamiliar. Light disappears, so communication becomes bioluminescent code. Food fades, so mouths become traps and stomachs become vaults. Distance expands, so reproduction becomes ruthless certainty. Pressure rises, so bodies become soft, strange, and strong in ways we don't expect. Alien is not a place. It's a set of conditions. And we've explored only a fraction of this world. Most deep-sea species may still be unnamed. Some may exist only in a single trench, on a single slope, in a single current. The deeper we go, the more the ocean reminds us. Life is not fragile. It's adaptable, but the final mystery remains. In a darkness this complete, how many evolutionary experiments are still unfolding, unseen? What forms of life are waiting beyond the reach of our lights? Not monsters, but answers?